in the diagram, the letter S is made from two arcs K, L, and MN. Now the arcs are these. The letter S is made from this. This is a letter S, which are each 5/8 of the circumference of a circle of radius 1, and the line segments LM. This is LM, which is a tangent to both circles at points K and N. Circles, yes. Then at points K and N, common tangents to the two circles touch one of the circles, is saying this one N, K. What is the length of LM? Right? So that's the thing, right? So you see, yeah, those are the arcs K, L, and MN that are 5/8 of the circumference of the circle. And we mark 2 points here, O and O dashed, which are the centers of the circle. The next thing is I draw the radius. So OL, OK, O dashed M, and O dashed N are the radius. So you draw the radius. The next we do is we note that radius makes an angle 90 degrees with the tangent. Right? So OL makes an angle 90 degrees with LM, and similarly OK is at 90 degrees with OK is the tangents. OK is the radius, and that makes an angle 90 degrees with the tangent. O dashed M is at 90 degrees with LM, right? So next we do is we join O dashed. And when we do that, we have got two triangles now. That is, we have OXL and O dashed MX. These are the two triangles we have formed. So the next step is we have to prove that triangle OXL and triangle O dashed MX are congruent. So if they are congruent, we can work out the sides, which is we are interested in LM. And LM can be found out by adding LX plus LM. Right? So what we do next is we work out the angles, and the first step is to working out the arcs. Okay, it'll help us to find the angles. So the major arc KL is 5/8 of the circumference. So this is 5/8. So and this one is going to be 3/8. See, the angle we're interested in is this. If we can find out this angle KOL, then we can somehow find out what this little angle is, because this is going to be 90 degrees. Because obviously OO dash is parallel to these lines touching. They are tangents, they are parallel to them. So that's 90 degrees. So then, and similarly the minor, so it works the same way for both the arcs. And now we know that the length of an arc is theta out of 360 times 2 pi r. If theta is measured in degrees, so in this case we take theta in degrees. And so we write it out that 3/8 of 2 pi r. So this is what we want to measure. So this is 3/8 of 2 pi r. That is the arc length. Okay. We don't write we don't put r equals 1 now, it's not needed. So we say 3/8 of 2 pi r equals theta out of 360 times 2 pi r. So that's the length of the arc. We are equating it to find that theta is 135 degrees. And next, what we do is angle KOL equals angle M-ON equals 135 degrees. So just this angles. They are 135 degrees, and therefore the angle, we need to find small these angles, right? So no, we need to note that this is 90 degrees. So angle KOX equals angle KO dashed N, and this is 90 degrees, right? So then we do the angles we need. We get the angles we need, that is angle XOL, this tiny angle, and we get XO dashed M, that is this angle. So we get they are 45 degrees. So and OL equals O dash M, and that equals 1. The radius is 1 they've given us. So what we can see is the triangle XOL is congruent to triangle XO dash M. Okay, and so LX equals XM. So we've got our proof. Without the 45 degree as well, you could have proved, because these are vertically opposite angles. So you could have done that, but we keep 45 degrees because we need to find out what LX and XM are. So then we do tan of 45 degrees is XM divided by O dash M if we are looking at this triangle. Okay, if you look at this triangle, so then that is opposite by adjacent. So XM is the opposite side, the adjacent side is O dash M. So tan 45 degrees we do, and that gives us 1 equals XM, or XM equals LX equals 1. So that gives us LM equals 2 units, and that's what we are required to find out.